speaker is Sevak Harutyunyan from Fontain, and he will tell us about another important topic, which is serving your model.
Hi everyone. Today we're going to talk about how to serve our models. This is a RESTful API. This is going to be a big reference. So let's start jumping to the outline. So this is Streetcar. Actually the key point, the end goal is to understand the model server. Before understanding the model server, we have to understand what's the API server first. And then, so okay, can you hear me, everyone?
Not here.
So, before understanding what the model server is, we first need to understand what's API server and what is a model handler, because it's just a composition of two. And for the sake of that reason, we just go slightly with the web part, understand what REST is, how sockets communicate with each other, and then the machine learning part. Actually, 2 points: what is a model file and what is a model handler. Actually, those are the 2 points that we need to understand in order to build successful model server. Then, after that, I'll give you some useful tips how to create your own model server or use So, first of all, everything starts when you create your awesome machine learning project, which detects a given image, whether it's a hot dog or not hot dog. It's actually from the series of Silicon Valley. If you haven't seen it, I highly recommend. And some of the companies want to use your product. They say, okay, wonderful feature, we want to integrate this solution with our system. For example, LinkedIn comes in and they say, we want to understand the user uploads a picture. We want to understand whether it's a hot dog or not hot dog. So how can we do that? The first and the most silly approach is give your computer, yeah? Because everything is there. You're writing, Python is installed, maybe PyTorch you've used, I suppose. You build this model and everything right there. You just write the picture and here it goes. It gives you a prediction whether it's hot dog or not hot dog. But let's talk about more seriously. First of all, in order to understand everything, we need to understand what is an API. So API stands for Application Programming Interface, and it's all about communication. So you do listen to me, and you do understand me because we speak the same language, and I know the address of you, so you can listen to me, and that's all. That's everything I need to make sure that my speech is understandable and useful. So that's why REST is basically an architectural style for web services that talk to each other. Basically, nothing more. Client HTTP protocol. So using internet. It's still the gold standard for public API. There are also many standards like RPC, which stands for Remote Procedure Call, and GraphQL. GraphQL is not used in machine learning heavily, but RPC is trying to get popularity because it's much more faster and lightweight. It doesn't use JSON to communicate with each other, with services, but it's not the gold standard for public APIs. And why do I misplacing public API? Public API is just telling another software to call my software. Any mobile application you have in your phone uses APIs. And they basically JavaScript code or Java code or C++ code, which was written in your favorite mobile application or desktop application or web application. They make communication with other programs. And what is the other program? Because the program which detects whether it's an update or not update. And the key elements are here defined on the server. So the client is your mobile application or web application. Actually, it's the code which runs the API and initiates the communication. For example, let's say almost any mobile application we use. And the server is a program, not an actual physical machine. Actually, it's a program. of course, run on a physical machine or virtual machine. It offers an API as a means of access. And the resource is a piece of data, very type. For example, RPC uses code files. In our case, we mainly use JSON, but you can also send whatever you want, plain text, heavy image, basically anything. And to get an access to resource client, the mobile application sends the HTTP request. In return, server generates some HTTP response and it returns to your mobile application. So REST request has actually many parts, but 4 essential parts are HTTP method. Maybe you know CRUD operations, create, retrieve, update, and delete. Basically, those are verbs. And mainly our clients use POST request, basically JavaScript application which wants to leverage Python machine learning solution. It just requests with the POST method. And the endpoint is the where the model lives. Actually, where your model server lives. Is the IP, physical or virtual machine, and the host, and also the endpoint. Headers, I'll skip this part, and body is the message you want to send. Basically, that much from Webb. We are not here for backend development engineering. But if you want to deep dive into this project, here are the resources, all the resources you need to be an expert or ace of this field. So feel free to check. But what's more interesting? So we are already in the ML field. So remember we talked about what it's a model file and what is a model handler. The model file is somehow, you already know model file, whether you have used it or not. I assume we have here Go, Rust, C++ developers, and you'll understand when I'm talking very well how to show the standard part. So you have wrote your hello world program in C++ or Rust. Rust was your cargo build or Go build, which generates an executable file, which is a binary file containing encoded sequence of instructions that the target system can execute dynamically and varies depending on your code. I mean, you can write hello world in many ways. You can create a function which will print hello world. You can just print hello world in the int main. Various ways to create your source code, but the actual end result, which is a binary file, will be different. So what about ML? You run Python train.py and it generates model file. So not actually you can't go home and write Python code train.py and generate model file. You need to write something in train.py. But the typical architecture is like this. You define your model, your actual model architecture, and in train.py you put scripts. How do you train your model? What are the steps? What is the loss? And how do you use your data? What features do you get from your data? Basically, if you run Python train.py, it will generate a model file, which is a serialized, compressed file containing the topology and parameters. Topology is the skeleton of your network, basically. Just a set of instructions which tells, okay, this is the convolutional block, this is the actual, this is the linear block, etc. And parameters are your weights and biases. But it cannot be executed directly by the system. It needs to be loaded by the model itself. So another difference is that it's not independent. You still need to load it into the model. And the most tricky part, it not only can vary depending on your code, it can also vary using the same code but with different data. So this already changes the whole situation. And we'll jump right into the model handler. So model handler is a program that takes an input model file and provides an entry point of prediction for the input given from the client API. So in real case, in real world, there can be also composite models. Your whole solution may also leverage multiple models. For example, a model written in TensorFlow which detects something, a model written in PyTorch which recognizes something and so on. So you can also compose, have a single model handler, but in this case the name actually correct because models handlers becomes models handlers. And it also can be written in other languages. So I haven't seen a case where people use nothing but Python for training. Of course, you can use libtorch for example, PyTorch, which is a C++ API, to do your training part, but I haven't seen a case to do that because it's much more time consuming, but at the end of the day, you'll get the same result. So everyone trained their code in Python, but not everyone write their model handler in Python. But we will see why, and we will understand why instead. Can I zoom in here? I'm not sure if everyone can see, but it's crucial point.
Always better to just put lights off.
Or maybe. Yes. And everyone can see, or vast majority can see. So this is a model handler written in Python. So it has basically 3 steps, but actually the end part is this handle function. So let's deep dive what it does. So first of all, handle function calls preprocess with the payload. Preprocess is a payload with type big. So we assume that our REST client is sending us JSON in this case, which will generate, so it will return a NumPy integer. So it's written that this function transforms request payload into the exact data type of network accepts. Basically, the whole meaning of the preprocessing is to transform the client, what the data the client API sent to you into the actual data type that doesn't exist in other languages. For example, NumPy or Tensor, they don't provide as the Java API for JavaScript or Java or C++ or Rust. And that's why the main reason is to preprocess that in order to meet the requirements to fit into your network. So after we get the network in, we just put network in for the model to call forward. I'll go this part of that. And we get network output. So after that, we give the network output to the post process, which is the actual return value to our client API. So basically, they want to understand where's given an image, where's maybe a text, maybe or some values, which will say about that or not about that. Okay, what's wrong with this? Not the reason it's written in Python, but people. I've seen cases, and in most, I've seen a lot of cases in the industry that try to override this model handler with another programming language. For example, Torch provides ++ API, TensorFlow provides Script API, and also there are language bindings. So there is a language binder for Go. For TensorFlow, it's actually, since it is written in C, they can bind the language and have the same functionality in Go, but not all the functionality, just for inference. And also they can have the same functionality in Rust. But what's the reason to do that? The main reason they want to speed up this process. But what if I tell you that this is the maximum speed you can have from writing your model handler? So this line is guaranteed to have your maximum speed, whether it's code from Python or from C++. So you can test it. You can go home, just upload it, just load the model in C++, model handler, libtorch model handler, and you can benchmark. You will get the same results. Maybe nanoseconds less, but it's guaranteed to have the same result. So the point is to speed up the self-post-process or self-preprocess. What if I tell you you don't need to do that too? Because you can leverage Webb, which is an LLVM compiler written in Python, and you can speed up this process and this process, logical parts, which use NumPy arrays, to have a just-in-time compilation process and have speed of C. I mean, there is no need to write C++ if you don't have basically the Windows performance. But there are, of course, some other cases like memory leaks or other overflow types. That's the reason they want to write in C++, or they want to handle a stream of files or stream of audio. This can be another reason to write in C++. Other than that, please don't do that. And another second point, I've said that model handler is dependent on the model file, but I can't see here a model file. Basically, model file has an extension for Python-PT, for Keras/5, and etc. But I can't see here any kind of model file. Why? Because it was already done for me. I have imported a model, which is in this case a Porsche model, and I've just set the tag train for its false, meaning that it's for inference, not for training. So the recognition model itself loads pre-trained weights in itself. So another useful tip, don't save topology, just save the weights. And if you save both topology and weights, so you can load and have a complete model, but in some cases it will break. Because not it will also break, but also if someone gets your model, it will retrieve all the information from your model. So basically just save the weights and upload it into your model API, in this case recognition model. As I've said, there can be also composite of models. For example, maybe my one model handler, which does some kind of magic, not only uses recognition model, but also uses maybe the detection model. So in this case, we have also self-recognition model, and we do the same processing. So lastly, this is our aim to understand what's the model server. Model server is a microservice that takes into the model handler and exposes at least inference API. So what's that? There are multiple already good model servers for you, written and well tested by the community. One of them is PyTorch model server, and another one is the Nvidia Streetcar model server. There are actually a lot of them. For example, Kubeflow uses TF serving, and TensorFlow uses TF serving. There is a model server for Fontain, and another popular one is Seldon Core. You can check them out, play with them, understand the model architecture. But all of them share the same thing. I will just show it in the PyTorch model server. So they have an inference API, but also have a management API. I'll basically skip this part. But for the inference part, there is an object running here which tells whose priority, which request has top priority or down priority, and it basically uploads the request getting from the client API to the actual model. So in this case, in our case, this is the model handler, which is a standalone working process. This is a model handler. This is also a model handler. And this is a model store where you store your binary files, the weights and biases. As you can see, it's not in the container. It's in a single physical virtual machine. It is just a single working container. It's not in the container, but all containers, so it's not. I'll also tell which cases are good. So another topics. So do you need real-time or batch inference? Basically, batch inference is for, in some cases, you maybe need to have batch inference. For example, some institution gathers data and they just once in a day send the whole data to you and you need to process. So in this case, you need to make sure that your network handles this request, not your API server. And there are some metrics you can read here. Some suggestions: make sure you use JMeter or AB, this Apache benchmark, to benchmark not only stress test, load test, but also understand your solution's limits in staging environment before shipping into production. Another point is that people often confuse this and say, whether we use asynchronous programming to speed up our Python code, it's not going to help you guys. Asynchronous programming will never help you in this case because in traditional cases, backend engineers will understand it. Actually, the endpoints are speaking with the databases. So the talking with the database is just an input-output long operation. For example, in this case, processor or the computing power of your machine will not do anything. It's idle. That's why it's wise to have asynchronous programming to do the other job unless this will return the actual value and move forward. But in our case, we don't have that. It's just our CPU and GPU is always running and it's always in heavy use. That's why asynchronous programming will never help you. And we can write our REST server in Python actually and mid-level, I can't say high level, but I can say high-level nodes, but with some cost, of course. There are actually two layers to write your REST server API. Is the server side and the framework side. People often confuse running Flask application with the Flask server itself. That's why they get lower metrics for throughputs and also for latency. But there are two types of asynchronous gateway interfaces and standard gateway interfaces, and there are also good frameworks. Actually, I haven't seen the difference in those frameworks. I'll tell you later. But I would recommend you choose one of these servers. And these are the tips and tricks. First of all, everyone uses Docker. So your actual container, your model server is just a Docker image, and the instance of the image is a container. Those are the options that can actually speed up. Those options actually have the incomplete performance. First of all, use multi-stage builds for the end result. So if you don't know what is a multi-stage build, in short, it's just in some point of time in the Docker file, you're starting from scratch and you're getting all the necessary components from the first bit which you want. For example, we have managed to reduce 2.5 gigabytes image to 500 megabytes in our company. So it's possible with the same functionality, with the same running computing power. We can increase shim size and also the shared memory size, and also maximize local memory address space. This would definitely help. And merge your model files with read-only permissions. Why? Because the server you are using to have multiple workers need to use preload flag and use shared memory multiprocessing. Because in the if you are using Unicorn, you will spin up a number of workers. For example, you say, I want 10 instances running in there, but you forget that your model actually is blind to the model file. And in the model file, if model file is 1 gigabyte in size, it will have actually 10 replicas of that 1 gigabyte. That's why it will make your solution bigger and lightweight. That's not what we want. That's the reason you should use shared memory multiprocessing with read-only permission. That will guarantee that your model file is used by all the instances, and you just have one single model file. And if you are using Kubernetes, please set Unicorn workers number to 1, because it doesn't make sense if you scale. Scaling provides Kubernetes for you. Otherwise, you can't possible. Actually, that's it. If there are any questions, if I have time, I just want to make another note. I forgot to say that you can actually put a number of, not just one model here, but you can put as much models here as you want. For example, in Python model server, this API part is written in Java, but I have successfully removed that in just one day. I tested with Rust, so it's so modular, it works very well. So you can do that if you want. And can handle also multiple models. So via the management API. You just also make some requests. You say, okay, I just want to put my model here, and I want my model served in the services. So that much.
Yeah. I have a question. Well, thank you for the talk. Very interesting. And maybe I don't understand it correctly. So you have the iTouch model server, right?
Mm-hmm.
So is that server itself give you endpoint,
Mm-hmm.
or you, and then why you have to write some web application with Plus or fast API? Is it an alternative way or
Good question. Yeah, I've said that there are existing solutions, so you can use them. But of course, they come with limits. For example, in our case, we had specific criteria that we couldn't solve with PyTorch model server. Just the example. In our cases, every model used another version of PyTorch. That's one case. Second case, we need to have shared virtual environments for each project. We didn't provide the API for us. We didn't have the functionality because the way Java codes or Python code, there is no way you can have your virtual environment. Everything is global in Python. Or maybe in the requirements.txt file you have private repository. Maybe from the private repository you want to download an application which is used by your model. So there are limits. That's why I said you are free to explore and understand whether this case is good for you. But in the standard way, this will work fine.
So iTouch is a service or it's a like open source tool?
PyTorch provides you not only the API to train your model, but also to deploy your model. So this is the API. So this is the tool. Actually, model server is a product. Yes, Sevak code, for example, Sevak code is paid-for. They don't open their source code. They say, okay, what they've done, just put your model in code. It's an open source version. This one is also an open source version. So you are free to explore the codes, understand what's behind it, and also optimize for your own use.
Maybe it's discussion how you're managing the requirements. Are you having your model serve in the same environment that people serve, or how you're deferring the development environment in a certain environment? Because it's a
we don't use tools like we do development by ourselves. So it's just a convention. Basically, we have also have a mutual agreement with our developers, with our data scientists, that all the models should live in this folder, first of all. And then we have a develop branch or master branch and a feature branch. So develop branch is always for if the push is made to the develop branch, the deployment, the CI/CD pipeline is triggered for staging the project. In the master branch, it's triggered in the production part. And if you, of course, our data scientists are free to explore their model, free to train whatever they want. That's why we have the same mechanism. After the training, trainings and results and the metrics are better than the old one. Challenger, the champion of the the challenger is better than the champion. So basically, we push the codes into the develop branch, then test it, and master it.
one question on this serialization. What is your policy? Are you inclined to write content serialization for every model, or are you using the provided one for Python? Which one do you use?
I don't have any experience of the second part. We just use the API that framework gives us to serialize. Basically, it does a good job.
Yes,
So if there are any risks or there are any problems, we should make the challenge together and understand what's the problem. But in our projects, we haven't got any kind of global pipeline or something went wrong, there is no message.
Thank you for the detailed progress. So how, when the model is retrained, and hopefully it will retrain with some frequency. In our case, for example, I can clarify how your endpoint gets the most recent version of the model.
The most recent version is up to you to decide how you want to do that. So model server, as I said, it just accepts the model handler, the model file, but the model handler is itself dependent on the model file. So you can just
There is model file. Is it on a database? Is it
it's an object store, Vimeo or something. So an object store for that. There are also conventions we use. For example, we store the train the models in the name of the repository, then version, then itself the actual model file and the kind of system.
okay? Doesn't it take more to read from an object store than reading it from local, like your local environment of the server?
Actually, in production, so in pipeline, there is no local mode. So in pipeline, when you trigger a pipeline, for example, deployment or training, everything connected with the model store. So if you want to do local experiments, you are free to do it.
In our case, for example, it takes less to read from local than from the database, as you have mentioned. That's why we have a
Okay,
job.
but how do you share your local files?
Yeah, so actually we have a job which is asynchronous, which copies the files from AWS S3 to local. And then this model, each time it takes is updated, like the model is updated.
Yeah, we do the same thing.
Yeah, so then the answer to my question is that you copy from the sound store into local, but it's done asynchronously. It does not, like during the handling the request, you do not read the most recent model.
Yes, of course.
Okay. Thank
It's
you.
already well tested, and we make sure that in production or in the UAT environment, we have a model version. We fixed the model, we already know in which code it was trained and which data it was trained.
The training does not happen automatically.
We have some projects that have the training pipelines, but not all the projects.
Okay, thanks.
And do you have any rollout control?
Right now, we are struggling having a beta version. That's why often we integrate that version together with SAP model version, because basically I said that this can vary depending on the code and data. In order to get exact running model file, we have the code version, which we have. But the data version we don't have right now, and we will investigate some solutions like UDC, for example.
Question about resources. How do you manage the resources? Say that under the knowledge for you? What are the common solutions that you use?
Should we know that one is knowledge deployed per day or?
Yeah, just the resources because it becomes.
In this case, we work with any scale. Basically, if you run with 10,000 models, it will work anyway. But if I'm not mistaken, your question is about if there are 10,000 models, where do you store? Where
The resources, the modeling resources, production, right?
Yep.
All of the resources in the latency, let's say.
Yeah.
So how do you manage that problem?
So it's pretty self-containing. So you have one server as a Docker container. You just keep the Kubernetes cluster and right now we have just one example of that, but it can be done. Both are manually testable and also
What are the common problems that you're experiencing in the production mode? Let's say besides are there any common problems that you're experiencing
problem from this side. I mean,
production?
Yeah, which part? Latency part. So we can solve the latency part.
How do you solve the latency resources?
Yep. So that's why I said your two building blocks are the model file. You can write in C++, save some resources, but also you can, in this case, you will actually not save resources, but you need to hire C++ engineer for that. you don't expect a data scientist to write C++ code. That's why I say there is no, this is guaranteed to have the same performance as C++ code. I mean, this is guaranteed. That's why, besides memory leaks and besides if you are not serving REST API, like stream easy or stream data. And like the place, this is one of the places where you need C++ or another one, but generally it's not going to happen. And another point
You mentioned in memory leak, so how do you solve the memory leak problem?
in our case, we haven't faced yet that solution, but the only method to solve that is to drop your mode handler in another language. Basically, there is no other way, as far as I know.
Okay.